sorry. We all know that AI is so hot, but how hot is AI? I did a little bit of research using the Google. So here shows the Google index of AI. You can see that from the year 2024 up to now, actually this is yesterday, we can see the people that are searching AI, the term AI on Google has been steady increase. There are two spikes. One is here, which is the year of 2012. And the other thing pickups here, which is November of 2022. Okay, so these are key moments. What's happening here? We can see the application doing object detection, like human detection, car vehicle detection, and facial recognition. Those are the main applications at the year of 2012. And this we call it deep learning. We call it deep learning, which is actually the essential technique is called CNN, convolutional neural network, which is happening here. But we can see the peaks dies down very rapidly, and like nothing happens here. So not major application except in security business, okay? And then what's happening here, which is the birth of ChatGPT, happens in November 2022, okay? And then it keeps increasing until now it's right here. So AI being increased every single month. And it has lots of new applications like digital human for marketing, those things. We call it, instead of deep learning, right now, we call it generative AI. And this spike here, now we call it AI 1.0. Now, at this, we call it AI 2.0. So one generation upgrade, so 1.0. We can see that AI right now becomes super hot. And what exactly is AI? I'm going to show you something like that, okay? So AI right now has been penetrated to everywhere in our society. The first application is chatbot, which has become very popular now, chatbot. Chatbot means AI-powered chat that can be interact with human like human beings. So it can be used to provide the customer service and also the provide the inside our organization to help training our staff or find out internal document. The other bigger application is Copilot. It's like you human are the driver, and we have another robot sit next to you, and can help us doing like programmer, for example, programmer. We are using the AI to replace the entry-level programmer. Like 2 years ago, if I have some idea, I need to have a team of 5 programmers to help me fulfill my ideas. Today, I don't need these programmers. I just need AI to help me generate full SaaS application platforms, okay, end to end. So these are the Copilot. Another application of AI is financial. We know financial is very important, and AI can help us to look at the stock market to detect the trading signals and can form its own strategies and can help human beings to place order and sell our stock, okay? In the science applications, in the science domains, we are also using AI to help us to design, to do the medical diagnostic, also the new drug discovery, and also in material science domain, people are using AI to generate the new materials. Of course, in recent years, the autonomous driving, like Tesla, released its FSD, fully self-drive. It's an end-to-end autonomous driving system powered by more recent generative AI. So it can mimic a human drive doing all the decisions. Okay, so this is really cool applications. Starting from this year, we are also seeing the AI on the headline, which is a human droid. So human droid involves place this generative AI in the form of a human. So it can not only do the reasoning, but also need to control the arm and the leg movement. Okay, so we can see, in summary, we can see that AI has been starting to penetrate into every aspect of our society. So what does AI impact our society? On the positive side, Goldman Sachs has this news. It says AI can push the Standard & Poor's SP Index 500 profits by 30% in the next decade. This actually means like 1.5% a year. So AI can significantly improve our working efficiency. Okay, but AI is a double-edged sword. We also see the news like this. This is last Christmas. Google starts to lay off 30,000 of employees because of AI, right? So they don't need the entry-level programmers now because, as I said, AI already did the work, right? So Google going to lay off 30,000 of employees. And this actually is last month in China. China's tech giant called Baidu, they released the robot taxi, right? I don't know if you see the news, but it released robot taxi on Chinese street. And in city like Wuhan, in the middle part of China, the taxi drivers already feel their job being taken over by AI. So they feel very, very nervous. So AI changes people's work, significantly. No matter if you want it or not, it's going to impact every single organization and every single individual. Okay, that's no question. But what exactly is AI? Okay, we have been hold this terminology many, many times. So I put it here. AI actually is, it's like a more cross-field, and it's twin. It has a twin. It's called a data science. Data science. So if your organization want to use AI, you must do digital transformation first, right? You must do digital transformation first. So you can collect and accumulate the data. So it's data science. The AI sits right here. And the AI, like 2 decades ago, it has another name called machine learning. Okay, we know called machine learning. And then machine learning is using human experts to do the data analytics. And then gradually talking about the deep learning. Okay, deep learning I will already show is like AI 1.0. And then after deep learning, we'll call it generative AI. I'm going to talk about that detail in the slides. And then another thing called large language model. And the other side, on the data side, we have big data. The mix between big data and LLM going to release and make a significant impact over the human society. So what is machine learning? Before AI, this is like early stage of AI. What is machine learning? For example, if we want to tell if an animal is dog or horse, how do we do that? So we take all kinds of, take a picture or take the measurement of these two animals. And then we use a human experts based on the experience to extract these features and then project those features into figures. Then we can see the features of a dog. Somehow they sit here, it's a cluster. And the horse is there. So we can draw a clear boundary there. So now we can tell which is a horse or a dog, okay? So we can see that we project the dog or features, picture or whatever into a hidden variable. Hidden variable, this terminology is some kind of abstract. But you can see at this hidden state, they actually, the attribute from dog sit together and from horse sit together. So we can draw a clear boundary. So this is called machine learning. In machine learning, we rely on the human expert to extract these features. Okay. But what if the thing is so complicated and a human expert cannot do anymore? What do? We use something called neural network to learn how to extract these features. If the neural network has many layers, in this picture, I only draw 2 hidden layers. If the neural network has many layers, more than 2 layers, we call the network is very deep. That's why it's called deep learning. So when the thing becomes more and more complicated, so human, you will see human become the human being are really exciting. You see, we have a powerful tool to replace the human expert. Just use this neural network to automatically extract the features, right? This is AI, deep learning. When the network becomes more and more deeper, we got a big problem. The problem is we got this vanishing gradient or exploding gradient. What does that mean? Means when you try to train this network to learn how to extract features, it becomes unlearnable. We cannot train it because we got this vanishing gradient problems. So in the past 2 decades, the whole AI industry and the academics are competing with these vanishing gradient problems. Along the way, now we are like AI 2.0. People are, the professor and researchers are keep proposing more methods to compact these vanishing gradient problems. There are lots of them, but here I'm going to just show some of them. One is called convolution. Instead of connecting all these nodes together, we call it fully connected network, right? People introduce some structure to it. Instead of connecting to all of them, you only connect to partially, a portion of them. So you actually significantly reduce the number of trainable connections. By doing that, we can allow the network to be deeper. Okay, this is a convolution. And the neural network is called a convolution neural network. And today, all the applications like facial recognition, car plate recognition are all powered by convolutional neural network. But when the network is going to deeper and deeper, a new problem comes. You got the vanishing gradient problem again. So people introduce something called a residual network. What does that mean? It means you actually train this portion first, and then you do a short pass here to let the information flow directly to next stage, and then repeat again. That way, we can better train the network. By doing that, we are able to push the network to thousands of layers. But still, we want to approach the human brain, right? Human brain is much deeper than this network. So we have the researchers at Google propose something called attention, which is part of a transformer. By doing that, we are able to learn a greater length of like text or time series. So basically, solve the problem again. But when the network going to like hundreds of billions of parameters, if you want to do tens of thousands of billions parameters, what do? You get this vanishing gradient problem again. So now the researchers like in OpenAI, they are proposing something called MOE, mixture of experts. So by doing that, you're able to train even larger network, which is on the same order of our human brain. So almost the same scales of a human brains. So we can see actually the history of AI is like this. Those are the key enablers of a modern AI. So let's look at from the application point of view. In AI 1.0, how we do AI. In AI 1.0, how we do the applications. So as I said, in the ML, machine learning, we have a human expert to extract these features. In AI 1.0, we use a neural network to extract this feature. This we call the deep feature extractor. So basically, up to this point, we use a neural network to extract features. And then we have something called a downstream task header. This is a small neural network just designed to do the tasks you have. So this is something called transfer learning. This is for the AI 1.0 to acquire new skills. For example, we have a neural network, AI, trained to do facial recognition. Now we want this algorithm to do car plate recognition. What do we do, right? This is a new skill. How do we do that? What we do is we fix this portion, which is deep feature extractor, and then we replace this task head, then we train it. By doing this, there are lots of problems. First, the organization want to use AI 1.0 need to have in-house algorithm engineers. For each new skills, you need to train it, right? You need to collect data and train this task heads. So this paradigm is not scalable. It's not scalable, okay? So that's why the AI, we see the AI being talked a lot, but you do remember the Google in-text trend. It's not that like a huge applications. So how do we enable the new applications? Let's look at the data, the human during the last couple of thousands of years, civilians, how do we develop these types of data? We have text. We have text data. It's a language. We have images. People have picture, image. We have images. We have videos. The sequence of image is video, so I didn't say video, okay? We have speech. We talk, so we have speech. And for medical, we have like CT, this 3D CT scan. We have medical images. And we have time series. So this is time series, like stock or demand, right? It's like the rainfall, rainfalls. Those are time series of data. And also, we have another forms of data, which is like this molecular, different atoms in the molecular, or the network or social network. Each people connect to each other. So we have those different kinds of data. If we want to use AI, we need to design a network that can handle this data. But the question right now is, which data is the most important one to human? Which data is the most important one to human? So this is debatable. People are saying that text is the most important one. So when we are back to the school, we are always reading book, right? When we communicate, our primarily is talking, right? Using text. It's language. So language is the most important type of data, which is this. Okay. So some people are saying that language equal to intelligence. Is it true? Is it true? So actually, language is considered a crucial component of human intelligence. So if we can handle language well, then we can say we design an AI that is intelligent, okay? So what is language? What is language? So we can see we are talking about like a facial recognition, car plate recognition, but the underlying intelligence is language. So if we can start doing AI for language, we can automatically solve the other AI problems. I'm going to come to that later. So now let's focus. Let's agree that language is a key part of AI, key part of our intelligence. So how do we do language? So what is language model? What is language model? Language model actually is just a probability function. It's being proposed by a scientist called Shannon in 1945 in the Second World War. So the probability says, for example, if I want to predict, or I already said that Bangkok is a city in. If we already said that, what's the next word? So the next word is going to be Thailand, or whatever. This is a probability. Okay. So this is a language model. Language model want to learn this probability. Our human brain is also doing that. When we are daily conversation, when people say something, you already anticipate what's the answer, what's the next word, right? So our brain is already monitoring, doing the modeling of this language. Okay. So how do we do language modeling? Before the AI, people are using this form called n-gram language model to model the human language model, okay? So if like a bigram just have 2, okay? If 3, just have 3. The longer the memory, the intelligence it is, okay? There is a rumor says a fish has a memory of 7 seconds, right? So the fish cannot be smart, right? So we need to have a longer memory to be smart. So how can we handle a longer memory? The answer is using the neural network we presented in previous slides. So when we use a neural network to learn this distribution, we have a new weapon, new mathematical weapons. We can model a very large, very deep joint probabilities. So with that, we call it large language models. Okay, now we know what the language model is, okay? So can we, if we already learn the language model probability, okay, language probability, we can always try to generate the next words based on the previous one. So this is actually GPT is about. GPT means generative pre-trained transformer. It's been invented by OpenAI. So the GPT says it has a special downstream task, In AI 1.0, we have many downstream tasks, right? What if we have a very special downstream task? It does nothing but generate the next word prediction, which is here. Always generate the next word. By doing that, it's called GPT. This actually is the core foundation of OpenAI. With this GPT, now when we design the new skills, we always doing this. Instead of design a new task head, we're using the fixed task head, means always generate the next token, right? So we acquire the new skill based on fine-tuning with the instruction data set without the change of the neural network. Now, if like your organization want to use AI 2.0, you do not need to hire an AI algorithm expert. You do not. What do? You just prepare a set of data, like instruction data set, that you provide to your new staff. So when the new staff comes to your organization, like onboarding, you're going to prepare some training materials, right? You just need to prepare this data to train the AI. The AI is going to learn similar to human being, okay, without changing the neural network structures. So the first it does is to pre-training on autogressive manner on the previous data, and then using fine-tuning. So by doing this, it significantly increases the application of AI 2.0, okay? So let's look at, with the advent of the AI 2.0, how the AI evolves. Here is the year of 2017, which is a transformer released. And then AI 1.0 is Google, because Google is so good at AI in the old days, AI 1.0, okay? So you can see nobody uses this path except OpenAI. So OpenAI is using GPT, means generative path. And because the model was so small, so it's not intelligence. Until the OpenAI released the ChatGPT, then everybody said, wow, what we are doing is wrong. We are always using AI 1.0 means we did something wrong. So everybody switched to here. So it's 2.0 pass. So now nobody actually is talking about this. This is called generative AI. So we can see along this way, the model size becomes larger and larger. Every year, the model size increased 10x. 10x. Now we are waiting to be the release of GPT-5. We can see if we still maintain the 10x. Okay, sorry. So what's the difference in these tech booms? Previously, we actually invented the invention of legs, like a car, arms, like all the machines, mouth, like we make phone calls, mouth and ears. But this time, AI is different. We are making the innovation of a brain, So this is going to be very different. So the path to develop the AI is like AI 2.0. It's just like, believe in right now, we are how to facilitate the adaptation of AI. Actually, it's just like a teacher. How we teach the student, how we teach the students is how we teach the new AI. Okay, so what do? First, we need to increase the students, the AI's vocabulary, which called tokenizer. We need to increase the student. For example, I have an AI which can be trained to only know English. So if we want to use it in Thai, what do? We need to increase vocabulary. Basically, we give it a new dictionary, and then it's going to pre-train, going to read all the Thai book, and then we're going to fine-tune based on the task. For example, we're going to do customer service. We need to do it. And then when we put it into use, these students have been trained well. When it's put into production, it needs to be like open book or closed book, right? So with the new information, basically it's more like open book exam. So we're using the new information dumped into something called a vector database to provide the context or background to this AI. And then finally, we use when in the beta application, human being can provide the feedback using something called reinforced human feedback to align the AI's value with human. It's just like when the students take the exam. When go home, we're going to check what mistake he make, right? And we provide feedback. Then the AI automatically correct itself to be aligned with our human, okay? These are new pipelines. But it's still debatable. Is the language the key? It's still debatable. The MIT actually published a paper in June. I think, yeah, it's in June. It says language is not primary tool for communication rather than thought. Do you agree with that one? Not many people agree. So when we are thinking, do you speak in your brain? Maybe you talk to yourself, right? But they say no. Language, when you thought, you don't use language. So it make a big impact, I think, in June to the AI researchers. So I actually found a book. This is a pretty old book, okay, philosophy book, okay, for Richard Gensling. So he actually said language is a mixture of realities, like math, music, everything. When you do logic, you need to also have a language. What we cannot speak out, we must remain silent. So that means language is the key to our intelligence. Now let's assume we're using the AI, we're using the language to build our intelligence. What do? We can project other data. We know the other data, like picture. We already talked about it, right? Picture, speech, right? And time series. We need to project those models to text because text is the key. So we provide a thing like here. What we need to do is text, which is the language, has an embedding, encoder. Image also have an encoder. Then they cross interacting with each other to align these two models. Then we add the new functions, new domains to the AI. Okay. Now let's look at some applications. One is for the vision. So what do? We add a vision encoder and the language encoder and then project to the large language model, which is here, which is a text. We get a new applications. What application do we got? We get image understanding. So we can understand the picture, not like just detect the face. So the AI now can describe what's going on in this image. We can do OCR. We don't need a dedicated OCR AI algorithms. So the large language model can do OCR. And also, now the large language model can do video understanding. This new capability never seen before. So for example, if I load a 5 minutes TikTok clip to AI, AI can tell us what's going on in this clip thanks to this vision encoding and the fundamental intelligence provided by these large language models. Let's look at the other model, which is audio. Okay, audio. Same thing. We use waveforms to project to the language model along with the text. Okay, with some small amount of training, now suddenly we can do SAR, speech audio recognition, can understand the language. We can do TTS, means can do text to audio. If you have some like a text, can turn back into audio. So we can do voice over those applications. And we can also, the large language model can talk while think. So just like the brain can talk, when it's talk, it can think at the same time. So this is an amazing thing of these language models. The other domain I'm going to show you is a time series of a multimodal. Okay, what do you have a chart, right? What do you have a chart, a stock market chart? What do? It's another domain. You can project it, same thing, to the large language model, okay, pre-trained LLM. Now suddenly we can do what? Using the intelligence of a language model, we can do stock prediction. We can do the supply and demand prediction. We can also do the hydraulic modeling. So increase new applications. And now we already understand what's going on, right? AI can understand. We want to like as a human being, we can talk, we can draw, artists, right? So we want AI from the understanding to content generation. Not only do analytic, but also to generate the content. We already know the language model can generate text, right? Generate text, GPT. It's generated something based on a probability distributions. So this is called diffusion. Diffusion, you can also sample these distributions and then generate the images. I will not go into details here because I'm going to run out of time. It can do text to image generation, text to video generation, text to music generations. So, and we already can generate stuff, but we want to go even one step further. We want to control the movement. If you look at our brain, actually our brain has 3 parts, but mostly we say 2 parts. When we say the brain, we actually means this neocortex, this region. This is, some people call it a new brain. New brain is for reasoning. So large language model is more like this reasoning part. There is one part that is missing, which is this part. We also call the little brain that controls the movement of our body, right? So when you walk, when you play tennis, you don't need to think. You can just go and catch it. How do you do that? We need to keep practicing until you have we call the muscle memory, right? So this is artificial intelligence. There's going to be a new domain for artificial intelligence for little brain. So now, actually, I'm also involved in the chip design for we call the little brain chip to do the AI to replace the little brain. Because right now, AI already doing this, new brain. Because by doing that, we can enable significant involve this human joint. Okay, you're going to start to see this human joint behave really like human. Okay. So, oops. Can I go back? How do I go back? How can I go back? How can I go one slide back? I'm sorry. Oh, okay. Now it works. So the AI 2.0 actually also changes how we design software. We all used to use the softwares like apps, those things. How do we use the new AI softwares? Right now in Silicon Valley, there are new terminology called AI automation. That's how you're going to use AI 2.0 in your daily work or in your organizations. I bet you must have a lot of data, like a mail. You're going to send a mail, you post on Facebook, you have like a Google data sheet, you have your Word Express, you have TikTok, you have email, you got Google Sheet. You actually, right now, we can design an AI flow to connect them all together and using the AI, the large language model as a brain to coordinate these things, automatically did it for you. So if you hasn't been attention to our AI automation, please. So right now in Silicon Valley, there are like 6 new startups providing this kind of tools. The other thing is when we are going to use AI, there is not one AI, okay? Just like our human, we need to have a team, right? So each guy is specialized at one thing, right? So by forming a team, each guy can do different things. We actually form a team. AI actually works a similar way. We fine-tune our AI to do each AI to do one specific things. Like one guy can do chat manager, one guy can do admin, the other guy doing UI, doing code, some guy doing like testing. By putting them in a same team, they can work together. Today, there are many kind of frameworks to do this, okay? So I already said what AI can do, so people are becoming really afraid. One thing is that AI doesn't replace human. AI doesn't replace human. Don't be afraid. But human going to be replaced by the humans that use AI. So if we don't know how to use AI, our job is going to be taken over by somebody that uses AI. That's for sure, right? So if you're already doing digital transformation, you already accumulate a lot of data. But this data just sits there to collect the dust because a human being cannot effectively analyze them, right? So even if you have some program or data that is fixed, right? It's fixed because you only analyze the data at this angle, point of view. So you want to use the data effectively, then you must using the generative AI to do it. How can we do that? We need to train our workforce to be better prepared for AI. There are 2 applications of a training workforce. The first one, AI actually helps training human workers. The example is we can use AI to train our staff, and AI can train our sales guy. I have one application. I know my time ran out, but really quick. We actually, in United States, we have French like refrigerator vendors. They have lots of new models every month. So they are really hard to find the salesperson that can sell these refrigerators or TVs effectively. What do? We actually made a special TWS earphones which can collect the monitor what's going on and then going to work as a co-pilot, tells the sales staff what you want to see next. So this is actually to sell, can train this sales guy. And also for maintenance, same thing. If the equipment, there are so many different types of equipment. If your staff cannot remember everything, AI can help. This is training for AI. The other thing is to train people how to use AI in the work. JP Morgan requires that all new employees will receive AI training, okay? and Hitachi, actually it is in June, they said they're going to train all their 50,000 of employees in AI. Why we need to do that? Because if we provide an effective training of AI, people are going to feel we are not going to be replaced by AI, but we're going to eliminate all these really boring tasks. So humans don't need to do these boring, repetitive tasks. We can focus more on innovations. That's what I'm saying. Okay, if we want to really compete in this AI world, we need to use AI to help us to drive the innovation and the growth from the production and the service, from the process optimization, from the decision making, and also, last but not least, for risk prevention and security management. Thank you. That's my presentation.
Is it on? Yeah, thank you, Dr. Liu. Thank you so much for your very knowledgeful presentation. And of course, we are trying to, me and my classmate will try to wrap up.